what? I don't like that. I'm gonna just move this over here. All right, so we will go ahead and get started. Welcome everyone to week 3, Failing at R. So today, if you saw my tweet a little bit ago, today we'll do a quick review of what we talked about last week, which was starting to get into tidyverse a little bit. And we're gonna talk about piping today, and not the kind of piping that goes with cakes with very precise floral work, but piping with our data set, so that way we can kind of like neatly arrange our code. So the code is up on week 3 if you want to follow along, and as always, this will be posted online for people to view. So as a quick review from last week, we started talking about tidyverse through 3 primary functions, talking about using filter to be able to choose observations in your data, arranging, which can be used for sorting variables, mutating is great for creating new variables and doing data manipulations, using select allows you to pick variables based on their names, and then summarize, which it was nice we had a little chat going. There's summarize with an S and summarize with an R, and you can use either. I'm going to use the British spelling with an S because that's what I'm used to. But if you are a fan of Zed, go ahead and use it. So we'll just do a quick overview of what those things do, and then we're going to quickly get into kind of group by and pipes. So again, if you want code from last week, week 2 is up under its own file. There's a more in-depth discussion, and the video is up there. So to get started, I'm going to load up tidyverse. And we're using the same data as last week. We're using the HSB data. And so if you've been with us the past few weeks, you can load up your HSB data based on whatever working directory you're in. I'm not going to review kind of how to set the working directory. We've covered that a little bit the past few weeks. If you need a refresher, again, you can probably watch one of the first few videos. And if you have not yet pulled the data, if you go to week 1 or week 2, there is an hsb.csv file. You can pull that. But wherever you have that stored, go ahead and read that in. And one of the things we talked about last week is that there is a conventional way of reading in your data, like a CSV file, where you can just use read.csv, and that's going to read in a data set that populates over here. Again, this data set has 6 variables with all these observations. And if we wanted to view that data, right, you could either click on it, that's going to open up the data set, or you could do something like type HSB, and it's going to start. Microsoft Teams is calling me. I guess it's trying to remind me about this. That's nice of them. So if we were to call the data set, it's going to look like this. It's pretty unformatted in a lot of ways. Instead, what you could do if you want to work in the tidyverse realm is you could read this in, instead of read.csv, you can do read_CSV. And so I'm just going to call this HSB Tibble. There's tibbles and tables. Tibbles are kind of tidyverse based tables, and they're formatted nicely. So I'm just going to read that in. And so you can see how it's reading in the different columns. These are all kind of being read in, I think it looks like integers with a double. They look the same number of observations, same number of variables. But if I actually want to call the table, it's going to show up differently. So rather than just kind of like an unstructured hot mess, you get like the first number of cases, you get the way that the variables are categorized, you kind of get how large the matrix is, negative values are in red. So you get a little bit more information with a tibble. So again, we talked last week about filter, arrange, mutate, select, summarize. So filtering is where we can select cases where in this data set, if I wanted it to subset this data, and if I want to subset the data to just choose females, we can just do that. You can just use that line of code, and you can see that we have just females equal 1. If I wanted to create a new data set with just females, I want to create an object called female that's equal to the filter. So the filter is just going to give you a tibble. It's going to produce something in your console. If you want to actually create a new data set, you can run that line of code, and it's going to produce a data set here where you can see roughly half the observations, which are just females. And then if you wanted to show both create a data set and produce a tibble in the console window, you just wrap everything in a parenthesis at the lead and at the end, and now it will both create the data and it will kind of spit out the tibble for you so you can view it. You can also do multiple filters. So if I wanted to include where female equals 1 and SES is greater than 0, filter is pretty flexible. Arrange is just a way to be able to sort the data. So if I run that, math achievement is now being sorted ascending. So by default, it's ascending. If you wanted to do descending, again, you just kind of put in DESC. Now it's kind of descending. Mutate, if I wanted to create a variable called deviation, so we did this last week, is we looked at the mean of math achievement. And so if we wanted to be able to know the students, each student's deflection from the mean, we can create a new variable called deviation. And deviation is equal to a student's math achievement minus 12. And so we now have a new variable where it's taking the individual student's math achievement, it's subtracting 12.75, and that's their deviation. Select lets you do a variety of things with selecting columns. So I could say, show me a tibble where I just select school ID, SES, and math achievement. And there it is. It's going to produce those 3 columns. And what's great about select is it's like, I think I use the example of just like me kind of being old if I forget what the name of my data set is. But I know it starts with an S. I can say starts with, and it's going to produce a list of variables that start with S. You can swap out starts with and do ends with. So if it ended with a D, it would produce like student ID, school ID. You could put contains. And so you could put any string value in contains. So if it contains, ing or contains E, it will produce every variable based on what you have in contains statement. And then lastly is summarize. And so summarize will give you a whole host of statistics. Again, in week 2, last week, I kind of gave some examples of all the different summaries you can get. You can get location, spread, rank, and position kinds of indicators. So you can go back last week and tinker with those if you haven't already. So if we do something like this, where we want to get the mean math achievement, we're just going to say summarize from Tibble and create a score called mean math achievement, and it should be the mean of math achievement. So that's really nice, but what's really great is when you start using kind of these 5 main things: filter, arrange, mutate, select, and summarize with group by. So group by is a way to be able to aggregate. So if you're familiar with SAS and you like to do your different procs by group, or if you're doing data management and you're wanting to aggregate data, like in SPSS, if you're going to use the aggregate function and you have a grouping variable, this is something like that. So the group by will be able to cluster together everything you do according to what you do next. So for example, one way to do this, so I kind of say summarize plus group by equals bliss. I mean, it's just a really nice way to be able to get aggregated information within your data set according to some kind of categorical type variable in there. So what I'm going to do first is create this data set that's called kind of by sex. So if I wanted to be able to do something based on levels of sex, I can create this data set called by sex. I use group by. And so create a new object called by sex, and then group the tibble by female. So group by follows that same structure as these other indicators, which again, you're kind of stating the command, you're stating the data, then you state the argument, okay? And so with summarize, you're stating the indicator that you want, which is group by. You're stating the data set, and then you're stating the command. You want to group the tibble by female. So in this case, we're creating this data set, which you can see by sex, and it's going to be grouped by female. And then what you do is you can put in your next statement like summarize. So summarize by sex mean math achievement, right? So this looks very similar to what we did up here. So this was summarizing the tibble and giving the mean math achievement. This is say summarize the by sex data set, which is grouped by female and produced mean math achievement. So if we run these 2 lines together, you can see that now you get the mean math achievement based on levels of female. So the mean math achievement for females is 11.9, and for males it's 13.6. We can also do this for something like schools. And so for those who are interested in multi-level models, and if you wanted to do a precursor step to kind of look at mean math achievement at a school level, to be able to identify whether it's to identify outliers or just to do certain type of work to look at the range. You can kind of create a data set that's called by school, and you're grouping the Tibble by school ID. You can then summarize that data set. So we want to summarize by school mean math achievement, and if you do that, you're going to start getting the mean math achievement for different schools. And within summarize, you can actually do a lot of different summaries together. So if we again create kind of a by school data set that's grouped according to schools, we could say, well, give me the count, which because this is aggregated, right? If it's aggregated, the count is the number of individuals within a cluster ID. So this is going to kind of tell you the number of students that are within a school. And we're going to also ask for the mean math achievement and the mean SES by school. So here we get then a school ID. And so for this school ID, there were 47 students. Right, and if we go back to the original data file, if we were to just kind of start scrolling down, it should be the first 47 rows, right, are 1224. So this is simply aggregating, and it's looking at the count, the number of N by school, the mean math achievement, the mean SES. So you can see that the mean math achievement for this school was lower than this school. The mean SES was also lower. So you can kind of start looking at some of the ranges, the number of kids that are in the school, etc. So you can start seeing the utility that group by doesn't necessarily work just by itself. So if you group something by, it's usually because of an intended purpose. Anytime you're aggregating data, it's typically because you want to do something else to it. So sorting makes sense because sometimes you might want to look at data. Filtering is usually helpful because then you can be able to look at the number of observations you have. Group by is really intended for a second step. So pairing it with these other 5 is really useful. So one way we could start pairing these in kind of a sequential manner and looking at these different elements of kind of FAMs and group by is if we just kind of pair, summarize, and filter together in a group by. So again, we're going to look at grouping our data by school. And then not only do we want to summarize the data and get the counts and the mean math achievement that we did before, but now we're going to take out all the schools that had greater than 25 kids. Oops. Right, so now instead of having 1,500 schools that we had before, here we just have 6 schools or 160 schools. Now we just have 6 schools. There were only 6 schools that had fewer than 25 individuals. So we still have the exact same indicators that we had up here, right? If we were to, again, do the by school and summarize, you can see that there's 160 schools in the data set, and we have all of these indicators. And then what this is doing right here is filtering out and only keeping in those that have less than 25 students. And so within that 160, there were 6 schools that had fewer than 25 students, and you can now look at their mean math achievement and mean SES. And so you can really start to kind of create and compound all of these different aspects. But this is a little bit of a more complicated way to be able to kind of build data off of each other. You can see that we have 3 kind of discrete steps. We're grouping a data set together according to an ID, and then we're producing some kind of summaries, and then we're trying to also filter the data. But what it requires in kind of just conventional R language is 3 separate commands, right? Create a data set, now summarize, now filter. But what if you wanted to do something more complex? So say you had this kind of question of what are the 4 highest mean school level Z-score math achievement values for schools with at least 40 students? So that would actually take a lot of programming to kind of write all of these steps in a sequential basis. And the code is going to kind of look a little bit messy. It's not going to be streamlined. It may not facilitate a lot of the analyses you're going to be interested in. So before we answer the question or show how to do that, I want to kind of take a step back that kind of leads into the main thing for us to discuss this afternoon is the idea of piping. And so piping is expressed in R through using kind of percent greater than percent. And so that is an intact kind of set of characters. And so you want to view it as one thing. And so when you see that in any code, you want to look at it and you want to read it as and then. Okay. And so anytime you see a pipe, there's going to be usually something before it and something after it. And it's showing an order by which something can happen. It's do this and then do that. Okay. So let's take, for example, when we want to view data, right? You can forget kind of clicking on the data set. I see Amy's asking by school not found. We'll come back to that one, Amy. I would want to make sure that the data is loaded and that you have the school ID variable in there. So I would, if you've read in HSB Tibble, I would make sure that you have this variable that's just looking like this, school ID. If it is, depending on when we finish up, we'll come back to that and see if we can kind of diagnose further, unless someone else is able to kind of help out. All right, so if we were to run this command, right, this is saying view the HSB Tibble. We've read that in, but now I want to take a look at it. That's pretty straightforward. In kind of in the piping language, if we view it as first this and then that, what we see here is a simple expression of how to use a pipe. Okay, what this is saying is first use HSB Tibble and then view. Okay, so it's just like this operationally. View HSB Tibble. It's almost like Yoda speak, right? It's like instead of saying view the table, it's like table you should view. Oh man, so piping is really Yoda-isms. I've never. That's awesome. Okay. Yes. Yeah. So week 2 data. So use the week 2 data because that has an additional variable. That has a student ID variable in there as well. I'll make sure to update that for next week. Thank you for bringing that up. Okay. So basically think about it like Yoda's talking. Okay. Instead of viewing the table, it's table you should view. Oh man, I love that I just stumbled into that. And so if you run that, it's the exact same operation, right? You get the exact same result. Now, while it seems like a weird way of being able to kind of program or write your code, it's actually going to make a lot more sense when we start to string together all kinds of different commands. But let's run through a few more of these examples. So we talked, I think, in the first or second week, if you wanted to view the first few cases in your data, you don't want to open the whole thing. You just want to get a sense for what it looks like. You can do head HSB Tibble, and that's going to give you the first 6 rows of your data set. Well, using a pipe in tidyverse, it's HSB Tibble, then provide the head of the table. And if we run that, you get the exact same output, okay? It's the same with kind of basic mathematical or, looking at like logarithm kind of thing. So if we say exponentiate the number 1, so use Euler's constant to get the value. When you exponentiate 1, we get 2.718, right? In piping language, it would be take the number 1 and then exponentiate that value. And we get 2.718. We can then kind of include multiple pipes. So multiple pipes would be, we would read this as take the number 1 and then exponentiate that value and then take the log of that value, right? So you can think about this as like multiple, it's not if then else, it's just do this, then do that. So it's kind of like doing do's in SAS language. So it's do this, then do that. So it's take number 1, then exponentiate it, then take the log of that value in a stepwise process. So if we run that, right, we get the number 1. And so we can do this with lots of different examples. Sometimes it becomes more complex, right? So if I wanted the maximum value for math achievement in the data set, I could simply do, max value of HSB Tibble data set, $ math achievement. So again, that's saying, the $ is to be able to identify kind of the object and the variable. So this is saying get the maximum value for this data set and this variable. And the answer to that is 24.99. In tidyverse language, we couldn't just do something like this, HSB Tibble max math achievement. So if we try to do that, we're going to get, it's trying to view it as an object. The reason is that max, like looking at maximum values and minimum values, it's not its own function. So looking at maximum values and minimum values and means, those are, remember, in summarize. And so instead of running max math achievement, we instead have to give the right command first, which is first look at HSP-Tibble and then summarize by giving us the maximum math achievement, a variable named max achievement that is the maximum of math achievement. I'm just going to call this, I don't know. Oh, you know, summarize, give me a variable called Jordan, which is the maximum of math achievement. And so we get that value right there. But suppose we wanted to be able to look at the maximum value for two variables, right? Let's say within HSP-Tibble, we wanted to know not the maximum of one value, where, you know, this code is certainly kind of more streamlined. It's faster, it seems, than this one. If we wanted to look at the maximum value or minimum value or means of multiple variables, we would need to do something like this, right? Maximum HSP-Tibble of math achievement, and then separately for SES. So we could run those two lines of code and get that, or we can pipe it. We can say, take HSP-Tibble and then, so take HSP-Tibble and then summarize both math achievement and SES and give us the maximum values for both of those variables within the HSP-Tibble data set, right? So now instead of kind of getting two separate lines, you get both values that are subsumed under the variables that you named them. So that's just a very quick way. You could break this out into two separate tibbles, right? You could do one tibble that summarizes the maximum for math achievement and a separate one for SES. We could kind of do it like this. Right, you could do that, and then you could do this. So you can run it two separate times, but again, just embedding it using the piping with the table function just streamlines it all. Okay, so just a couple examples, because I always find that more examples helps. So going back to like the filter example that we started with, if we wanted to filter and just select females, we can do filter this table with this command. So just retain females. Using the piping, we can say take Tibble and then filter where you just keep female. So we get the exact same result. It's just kind of streamlined it a little bit more. Now, what I've shown up to this point with all of the pipes, right, are operations where everything is getting put into the console. So whether it's showing the first set of values here, where the answer kind of comes up here, if we're exponentiating the number 1 by saying here's the number 1, exponentiate that value, the answer is populated in the console. But as we've talked about the last few weeks, we almost always want to be able to create separate data sets that are filtered or arranged or grouped in some meaningful way, right? So we can still do that using the piping. And so we could say create HSP female. And so HSP female, yes, you can. You can set the number of decimals. I don't remember it offhand. Someone smart might be able to populate that answer. But yeah, you can absolutely round things to like 2 decimals, 3 decimals, etc. And you can do that within, I think, summarize somewhere. So if we wanted to be able to use the piping to help create a data set, we can do it like this. So create a data set called HSP female that's equal to Tibble, the Tibble data set, and then filter where we're just keeping females, right? So we're preserving the exact same structure as before, we're just putting it in this new object. And so the structure for kind of creating a data set, it structurally looks exactly like above here. We're just putting it into an object like we've done before. Just for kind of code cleanliness, what I end up doing is putting new pipes, or whenever I have a pipe and then it's, you have a command and then it's, do this, then do that. I try to put the do that or the and then on other lines just for cleanliness, because it makes it hard if you do one pipe, it's easy. But as you add more pipes, it just gets a little bit wonky. It also makes it easier for kind of testing. Let's say you get an error in your code like I do, it's easier for me to be able to isolate different errors in my code by kind of stacking, the filtering. Thank you, Amy, for putting in about decimal places. That's awesome. So you can run it this way, right? So now I've created the HSB female data set. It's identical to the female data set we created before. This is just doing it with a pipe. Or if I put this on the next line, I can put the cursor anywhere, right? And it's going to run it. I can put it on the Tibble line. I can put it on the filter. It's going to run the entirety of that command all at the same time. All right. Just for another example, if I was to arrange the data set, right? So I can arrange it that way, or again, I can do it the other way where I can say take Tibble and then arrange by SES. Now, if for some reason I wanted to actually create a data file, if I wanted to export a file that was sorted, you can do it the same way. So I want to create a file called HSB sorted, and that's going to be a function of taking HSB Tibble and then arranging according to SES. So if I do that, then when I come here, right now it's sorted according to SES. Why I would do that, I have no idea. Because if I just open up SES, if I open up HSB Tibble, I can always just sort it by SES. But then if I close it out, right, and open it again, it's going to be back to its original format. I assume that with HSB Tibble, with the HSB sorted, so it's sorted this way. If I go like this, so it's sorting descending now, and I close it out, what it should do is preserve the original sorting so it's ascending, which it does, right? Because that's what you actually created, was an ascendingly sorted data file. So if you want something like that, then, well, there you go. Okay, so that's a little bit on pipes. So a lot of this is, I know it seems like a lot of examples. Hopefully it's just making it salient, because when we get to something like, hopefully, well, it should be next week, where we're going to get into merges. Data merges and using pipes and analyses are all kind of like integrated, I find. And so it took me a little while to master pipes, because I'm, well, not even master. It took me a while to feel proficient with pipes. So hopefully you're feeling more proficient faster than I did. So sorry, my wife is texting me about or something. Yeah, my little buddy isn't here today. He is napping. He's actually taking a nap. So blessings all around. Okay, so let's go back to that question that I kind of asked before, right? We were talking about integrating different aspects of filtering and arranging and mutating. So if we were to ask this question, what are the 4 highest mean school level Z-score math achievement values for schools with at least 40 students? There's an old school way. There's the way that you might conventionally do it in R that is syntactically correct, that you'll get the right answer. And I want to show you how you do that, and then show you how you can do it in tidyverse in a more streamlined way with pipes. Okay. So if we want to answer this question, what we might start with, right, because we're asking for Z-score values. Some of this, again, is from last week where we did this work. So the first step might be creating a new variable. And so I want to be able to have a new variable in this data set that contains both the deviation, right? We did that earlier where I'm taking the mean math achievement. I'm using that and subtracting into kids' individual math achievement, and then creating a Z-score from that based on what I know the standard deviation to be. So you can, this is from last week, within a mutate statement, you can call a new variable that you're creating within the same mutate statement. So deviation doesn't already exist in Tibble, but I can create it in this line and then call it in this line. That's a really great function. Is you don't have to create it in order to use it. You can do it in the same step. So step 1 here is creating this new variable. That's a Z-score. This is, you'll note it's at the individual child level, right? So we've got the student ID. Each of these 10 students have their own Z-scores. But now I want to be able to group by school, right? Because this question is asking about school level achievement. And so it wants school level achievement with a certain number of students and a certain threshold of achievement. So I'm starting by creating the individual child level Z-score because I can't get a school level aggregate of the Z-score per se without first getting the child level Z-score, which is helpful. So what I'm going to do next is kind of group these data by school ID, and I'm going to create, like we did earlier, a by school data set. So this is kind of organizing the data by school. So I'm grouping within this data set all of the variables according to school ID. And then I want to create a new data set called school sum. So this is just where I'm kind of summarizing the data. So now that I have individual child level z-scores and then a data set that groups those z-scores based on the school ID, I can now get the mean math achievement z-score as well as the count, the number of kids that are in each school in this third step. So this goes back to what we did earlier, right? You can do multiple things within the summarize statement. So if I first group my data according to school ID, then summaries that I get from a group by data set will produce it at a school level. So that's why here I only have one row for school ID 1224. It's because I've already grouped the data according to a school ID, so all summaries are according to that grouping factor. So in this school summary data set, so I'm going to summarize my grouped data set, and in that I want the counts, so I want the number of kids per school, and I want the mean math achievement z-score, which is the mean z-score that was created. And when you do that, you get this data file right here. And then the last step within this sequence, or at least one of the last steps, right? So it's the 4 highest mean school level z-score math achievement values with each 40 students is I can filter. So I already have the aggregated mean math achievement. So I have school level math achievement, but now I have all the schools that have the number of students. So I need to filter out all of those schools that have less than, right? So this is saying filter. And so include in this data set those that have at least 40 students. And so if I do that, then it's producing that right here. And then if I just wanted to select the variables that were of interest, I can use the select function, right? And so I had all these other variables in there. I can just choose the couple variables that I want. I might not want all 3 because I already selected schools based on their count. So now I just want the school ID and the mean math achievement. And then I can arrange those. So these are kind of out of order. So if I want to quickly know the first, the 4 highest, I can sort descending the math achievement. And so now the 4, so the 4 highest mean school level z-score math achievement values with at least 40 students are these 4 schools. Right, so this is a very long way, but it's technically and syntactically correct. We can create the data at the child level. We can then aggregate it at the school level. We can filter it based on the indicators that we have. We can reduce the number of variables in the data set to those that are of interest, and then we can sort the data to produce the answer. All right, so now I want to show you how you can kind of take this old school approach and be able to add pipes to it to actually make it a little bit more streamlined. And I want to use, before we get to kind of like the main code where you wouldn't have kind of step 1 through step 6, I actually just want to show you how you can do that with these same 6 steps using the pipes. So what we would do is start with HSV Tibble, because that's what we're working with, right? Up here, we didn't do that. We just said kind of mutate this, and then we're creating all these new data sets all along the way. You can see this is a new data set, this is a new data set, this is a new data set. It all populates over here. In each of these 6 steps, we're creating a new data set, and then we're doing something to it in another step. With pipes, you don't need to do that. So here what we're saying is from HSV Tibble, take HSV Tibble and then mutate the data, right? Create this z-score. After you do that, it's and then group by school ID, and then summarize the data, and then filter the data, and then select the variables that we want, and then arrange the data. Okay, so I want to kind of go through that again. So using pipes in Tidyverse, we can start by identifying the data set and then sequencing all the different steps. We get rid of all the junk of having to create new data sets, and instead we just retain the commands. So we no longer have new var, by school, school sum, school filter, school select. We don't need that anymore. because we're going in a sequential process that's going from HSP Tibble to a final result by just using commands that are intact to tidyverse. So first we're going to create the z-score, then we're going to group those z-scores together at the school level. Then we're going to summarize those. We want to be able to get the number of kids that are within a school, as well as the mean math achievement. And then we want to only keep the schools that have at least 40 kids. Then we want to just keep the school ID and the mean math achievement, and then sort it so that way we can get it. And then instead of having to run, right, each of these, we have to run that step, then that, then that, then that, then that, right? You have to actually run every single one or highlight it. Here, you only need to run, you could just put your cursor here, and it's going to run the entire command. Because it's viewing it, every pipe is connecting it together. There's a connective tissue. And so you're actually running kind of a whole series of commands, but within one step. And you can see here that you can just highlight it and run, or again, you just put it wherever you want within any of these steps. It's going to run the whole thing, and you get the same result. All right, we can then condense that, right? We can take out the steps, and this is kind of what a cleaned version of piping would look like. So we again have the Tibble, and we could just outline all the steps of take the Tibble and then mutate the data, and then group by school ID, and then summarize the data by getting the number of kids per school. Also get the mean math achievement of the z-score, then filter, then select the variables that you want, and then sort it. And when you write it, you again get that data. And you can change anything in here. You can add more, you can take out more. I could take this right here and say less than 100. You can add other pieces in there, right? So there's that. I can take this out. So now this is using this is ascending, which is by default. So you could get the 4 lowest schools there. You could expand on this. By school ID, so we could get oh yeah, I didn't. Oh, I did it wrong. Oh, yeah. There we go. So now we can get those kind of variables. So you can see that this is pretty flexible. You can group any variable together, and you can kind of choose and manipulate anything within each of these own functions, right? So you could have this go as far down as you want in terms of summarizing and filtering and mutating. So like that's a really brief intro to pipes, it seems. As I kind of predicted, I'm a little bit under on time and showing some things today. So I apologize. I thought that might take a little bit more time. But I think this actually gives us a good foundation for getting through some of the initial parts of tidy that are going to then lead into when we get into data merges, because data merges are where we're going to start thinking about how do you merge one data. If you have a large data and you want to merge in variables, if you want to concatenate cases, if you've got 2 data sets that have 2 different sets of data in them, no common variables, there's a lot in there. And so we'll kind of pick that up next week. So I think that's what I had for this week. Again, sorry it's a little bit short, but with the rest of the time, can you compute the mean in the pipe? Yeah, that's a good question. So I know you can do yeah, you can compute a mean in a pipe where you can do something like, go down here. Well, no, you can create variables within the pipe, but I'm not sure if you can actually compute it in it. You can produce it, I think, right? Like summarize. You can call a mean, but I don't know that you can compute a mean in that same way, if that's what you're asking. Usually it's just the mean of the values within that, but then you can use those estimates in creating new variables. I hope that's answering. Okay, so what we can do with the remainder of the time, for those who would like to get to kind of other things that they have, next week is again going to be data merging. One question that I would ask, and whether people want to put it in the chat or otherwise, yeah, and so that's what we covered before is, yeah, you can do math achievement minus mean math achievement. So you can use the mean, you just can't compute the mean outside of it. So mutating allows you to be able to create that variable. So you could kind of substitute right here. So you could say mean math equals math achievement. So you could do something like that, where then you can kind of look at deflections that way. That's one way to do it. So for next week, sorry, not for next week. So week after next was when we were going to transition from some data management into data analyses. So a couple questions that I think I would want to hear from folks are, do we want to keep going with some more data management kind of post thinking about merging data together? Like, again, the three broad topics people were asking about was data management, data analysis, and data viz. So I'd like to try to stick to that, but if folks are like, this is helpful, but more data management would be great. The other piece would also be getting some feedback on the types of data analytics people would want to learn more about. And the reason, a few clarifying things there are, I think so my background is I'm a quantitative methodologist, so kind of statistical analysis is a little bit more my bread and butter. I feel a little bit more proficient with those things than kind of data management. And so there's a wide array of topics we could cover when it comes to analytics, right? We could talk about basic linear regression and ways to do kind of basic multiple regression, moderation with simple slopes, mediation. We can kind of talk about how to do that in R, but we could also kind of jump to things like multi-level models, explanatory item response models, diagnostic accuracy, quantile regression, like really get into advanced analytics. I don't have a good sense, just because we're all getting to know each other and it's usually just me talking, of what people would really be interested in learning. And so one thing, I guess, so as you're thinking about or commenting on what you'd be interested in learning on analysis, is whether you'd rather go deeper on maybe 2 topics. So we could spend 2 weeks on multi-level models and try to go deep there in terms of analytics. 2 hours is not enough, but we could at least start, and I could kind of show how you do a lot of interesting things with multi-level models in R. Or we could do kind of a light overview of 4 different topics. So I'd be curious to hear what people are interested in learning. Again, it could be everything from kind of individual differences modeling, causal modeling, and not SEM, but just more like thinking about impact studies, how you kind of establish causal mediation, or even just kind of like between group, how do you establish baseline significance, quasi-experimental analyses, or psychometrics, kind of doing Roche models, 2P models, vertical equating and scaling. Yeah, so just keep populating those comments. That's really great. Thank you, Anna, for sharing that. So we'll take a look at that. I do know so depending on what the topics are, one of the things I'll let you know about is one of my friends and good colleagues at University of Connecticut, Betsy McCoach. She's going to be doing some things on, I think she's going to be doing an R course, an open science R course on multi-level models. And she and Ann O'Connell kind of wrote one of the seminal books in education on multi-level models and ed research. So kind of next to Raudenbush and Breich, kind of O'Connell and McCoach are some of the leading statisticians on multi-level models. So Betsy's going to be teaching that this summer. So if it seems like more people want to do kind of like single level analysis, looks like a lot of people are saying multi-level. Maybe we'll do a little bit of an intro, because part of multi-level models, it assumes, right, some things in terms of random effects that are broader than what OLS does. So maybe we'll do a 2-parter on multi-level models, where a little bit of time showing the linear regression, and then we will branch out into maybe some multi-level models and structural equation, and then maybe a little bit for the data junkies interested in thoroughly covering the basics. Okay, so we'll kind of see how to do this. The other thing two more comments. So for Anna or Anna, I will send a link out to the group in terms of how to sign up for that open science course on multi-level and SEM. That may be something that Betsy and I are actually co-teaching. We're trying to actually figure that out right now. The other is I do have, this is looking at post-summer, right? This is just like, hey, let's have some fun on trying to learn some things and screw up together, but it really is for the purpose of then being able to do modeling. And so two things I want to throw out there that are available. One is this fall. It's a little less relevant to R, but in this fall, one of the doctoral courses I teach is how to write a grant. So it's an advanced research methods course where you basically learn how to write an R21 or an R01 in the National Institute of Health mechanism. So you do learn a little bit about analyses, but it's more about how do you design studies that can get funded. That's an open science course. Anyone can jump in. But then in the spring, yes, that is totally open that people can sign up for. I'll do a call for that later this summer. The other is next spring in January, I teach in advanced analytics where I teach 7 different topics. It's about 6 hours per topic on a lot of advanced analytics. So if we aren't able to get to that now and you don't have any coursework planned or you're just interested in learning, granted this is January, I mean the world could end by that point, who knows. But I'll be posting some of that kind of information over time. So if people are interested in joining those sessions, they can. It's the same as this where I record all the sessions so people can kind of learn at their own pace. But those end up being 6-hour kind of blocks where 3 hours is about theory and 3 hours is on analytics. So that could be some, if of interest, we can kind of do that. So yeah, with the remaining time, I'll just kind of be here. People can feel free to jump off if people have other things to do, which I know we all do. So thank you. If the world ends after I learn R, I'll be super upset. Well, you know what? It's like I'm already avoiding having to learn Python. So it's like, I don't know. I'm with you, Kelly. So feel free to jump off. We'll post this, that's a shorter session today, but I'm sure it's better to be short than long on these things. So please let me know feedback on analyses. A lot of people are doing that. I'll send out information on the course Betsy is teaching. And then we will look toward next week where we do get into data management. And depending on where people are, we might do 2 weeks on that. We'll just have to see how long it takes for us to really feel good. I would also love, just like if you wanted to send me direct feedback, things I could be doing to either help or facilitate things better. If it's like, could you explain things slower or more examples? I believe in intellectual humility. This is the first time I've done something like this. So any feedback to improve things, please let me know. So thanks for joining. I'm going to stop the recording, but people can stay on if they want to talk about data, methods, design, Airbender, whatever it is. So thanks for coming. We'll see you next week.